Hmm. First protocols we will discuss. After that we'll go for Verilog, and then we'll go for system Verilog, and then UVM. Okay. So up to now we had discussion about this CSI C-PHY layer and D-PHY layer, how the CSI part is transmitting the data from transmitter to receiver, and what are the architectures, and what are the difference between the C-PHY layer and D-PHY layer. And then PHY layer we have in that CCI part we have uh, two different write operations and four different read operations. We have discussed about that, and then how the data is transmitted by using data frames and then packet format. All these we were discussing, right? Similarly, we need to discuss about the file layer. So this file layer, how the data is transmitting, right? From the transmitting side to receiver side, we need a transmitter and receiver, right? So from the transmitting side to receive, yeah, yeah, yeah. Okay, okay. How it is looks like? Just give me a minute. So file lane management layer. Okay, so CSI lane management layer, we are having the physical layer. In this physical layer, we are having two layers like a D-PHY layer and C-PHY layer, right? So C-PHY layer, that is MIPI 01 and then MIPI 02. So in this way, we are using two different file layers. One is C-PHY layer that is 1.2 version, and D-PHY layer that is the version called 2.1 version. Okay, I told you in the transmitter side we are using C-PHY transmitter side, and the receiver side we are using in the transmitter side we are using D-PHY, and the receiver side we are using C-PHY. That cannot be allowed here, and we need to use the transmitter side D-PHY as well as C-PHY. D-PHY is also used in the receiver side, and don't allow that C-PHY is in transmitter side and D-PHY is in receiver side is not allowed. C-PHY you are using transmitter side, and then C-PHY only we are using at the receiver side. Okay, so D-PHY physical layer option, how the data is transmitting. See, we are using D-PHY layer, data is separate, data and clock both are separate, right? So data is sending separately and then clock is sending separately. Here two lanes we are using. In this D-PHY layer, two lanes are there. Up to it will support 1 to 4 lanes. Maximum 1 lane to 4 lanes it will support. One clock lane and two or more data lanes. Okay, two or more data lanes we are using. See, this lane 0 D0 will be using, and lane 1 D1 will be transmitting, and lane n minus 1 Dn minus 1 data will be transmitting. So all these differential pairs are high speed data lanes. So all these lanes are high speed data lanes, and the clock lane we are having either a DP layer and then DN layer, differential positive and differential negative. So in that way we are transmitting the data from transmitter side to receiver side. How the clock is behaving in your D-PHY layer. Clock is always in continuous type of clock we are using. That is mandatory to transmit high speed data from the transmitter side to receiver side. Okay, so we are transmitting the packets type, different data packets we are transmitting. That means high speed clock is always active. Then only we are transmitting the data. So that is the continuous clock. Sometimes non-continuous clock, that is an optional. So in this low power modes will be there. Sometimes the data will be in idle condition. So at that time low power data will be there. In this low power, we have four options 0, 0, 0, 1, 1, 0, 1, 1. So it is in idle condition 1, 1, and then active condition 0, 1 or 1, 0 we are taking that. So based on that, different lanes will be using here. Okay. So the minimum D-PHY lane requirements. What are the minimum requirements for the D-PHY lane? Here we are using unidirectional master. Okay, what is the unidirectional master means? See, data is transmitting unidirectionally. Okay, from the transmitter side to receiver side, we are transmitting. That means high speed transmission lines we are using, and then low speed power transmissions are using. Okay, low power transmissions are using. Okay, so from that we are using some CILs like clock interconnect layers are used. These clock interconnect layers are used to communicate between the master functionality enables. Okay, how we are connecting the signals with the master functionality enable pin, how we are connecting with the clock interconnect layer, it will take care of that. In the same side, receiver also we are maintaining the unidirectional slave interconnect. So yeah, so that's it. Clock interconnect layer. Yeah, yeah. So this clock interconnect enable why we are using means see the clock is transmitting right, but we are using one lane. Okay, this lane having a wire. Okay, so that wire we need to communicate it. How we are communicating means interconnect is used. Interconnect is used to connect the two components. Okay, one device is there. This is one device. This is another device. In between that, we are using in interconnect. Okay. Similarly, clock interconnect lane we are using. That clock interconnect lane we are using to connect that different convolution networks, all these things. Okay. And similarly, we have um, receiver side also unidirectional slave is there, and high speed receiver signals are there, and low power receivers are also there. And same how the master is enabled, same way slave is also enabled for the clock interconnect lane. Okay, and then ultra low power speeds are also we are using. That means some forward escape functions we are using that. So that forward escape functions we have ultra low power systems are used. Okay, ultra low power means compared to the low power, it is still more low power is used. Okay, so that is the purpose of ULP supports we are using. That means even small power is also there, then it will operating the it will enters into the operating condition. So that is the ULPS supports, ultra low power supports. Okay, ultra low power speed support. And then D-skew calibration. What is the use of D-skew calibration? Okay, D-skew means say uh, here CSI is used to data transmit the data that is high speed data, right? This high speed data we are transmitting from the transmitter side to receiver side. At that time, all are not transmitting at the same time. So lane 1 is starting first, after that lane 2, and also lane n minus 1 is there. Okay, so lane 1 is communicating fast, and lane 2 is communicating slow, and lane 3 is see different data bytes are transmitting from transmitter side to receiver side. We are using two different lanes. That means two runners are running on the two different tracks. One track is the slow track, other track is the bumpy track. That means some speed breakers are there. Okay, that means the two persons running in different way, right? So then two persons are also receiving at the receiver side in different time. So then this queue will be takes place that so who are coming first, who are coming last, so that will take care of that, and also uh, align that to what however the data bytes are there on reaching from the receiver transmitting side to receiving side. So that will align and then transmitting to the receiver side. Okay. So that is the DSQ purpose, DSQ calibration, receiving the data in different order, and then it will arrange that who is coming first, who is coming last. So after that, all the data should be arranged in the same order. N will be first order, N plus 1 will be next, and N plus 2 will be the next. See, it is automatically arranging the order. That is the skew purpose we are taking. So alternative low power states, why we are using means suppose, huh, skew, this, huh, this skew, 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 skew. How we are pronouncing Q? Same way, skew. Okay, fine. So alternative low power states are also it is supporting that. That means sometimes low voltage, low power signals we are giving. At that time also it is supporting that to transmit the data from the transmitter side to receiver side. That means it will reduces the leakage current. Alternative low current we are using means whatever the current leakage is there, that leakage current will be reduces. Okay. See, we have different low power state LP11, LP10, LP00. So different low power states will be there. Some idle condition and then busy condition and active condition. So different low power states will be operating here. Okay. Similarly, how D-PHY we are explained. Similarly, we have a C-PHY physical layer. I told you C-PHY layer is composing of one or more unidirectional lanes here. Okay, one or more unidirectional lanes, and there is no separate clock lane. Okay, clock lane is no separate clock lane is there. Embedded clock lane will be transmitting. Similarly, we are using trios. Okay, each trio three wires are there. One is positive, negative, and then positive, negative. So in this way, we are using different trios. We are utilizing in that C-PHY transmission layer, C-PHY physical layer. Okay. So in this C-PHY physical layer, we are transmitting the data from the transmitter side to receiver side. So we are using three wires. That means trios. So in that, two or more data lanes are there, and then all the data and control signals are combined each other. That's why all the lanes are different lanes. In each lane, data is sending, and then different data bytes are sending. That means byte 0, byte 1, byte 2. In that way, we are sending the data, and sometimes in between the each data byte, we are using that synchronous signals. So synchronous words. Why we are inserting the synchronous words in between the data means to get the data in the aligned order. So for that purpose, we are using the synchronous word support. And here also we have ultra low power states are there. Ultra low power states means when you are doing some implementation of C-PHY layer, it will support that ultra low power states. That means even low power also we are using. At that time also it is operating mode. Okay, so then it is not even, that means zero point 0.1 volt, zero point 0.2 volts. So very low volts also we are giving means that will be operating. Okay, and then alternative power states are also reducing the leakage powers. Okay, and then ESDs are also reducing. That is the purpose we are using um, alternative low power states. And I told you unidirectional master is there, unidirectional slave is there, and then high speed transmission lines are there, high speed receiving lines are there. Similarly, low speed low power transmitters are there, low power receivers are there. Same points here also repeating, but in between that synchronous word support is there. In the payload time, all the lines are will be synchronous. Clear? Is there? Hello. Okay, Fine. See, these are the differences between the D-PHY layer and C-PHY layer. So here two wires are used and here three wires are used. That means each lane two wires are used and each lane three wires are used. And then explicit clock is there and then embedded clock will be there. And data lane and clock lane both are different lanes and then data lanes and clock lanes are combinedly sent, and here high speed transmission timing clock lanes are there. Here synchronous words are there. Okay, low power states LP111000 will be there. Here low power states with alternative low power states are also there. Okay, so that is the basic differences between the D-PHY layer and C-PHY layer. Who is widely used means, so D-PHY layer is widely used, and here pin counts will be more in C-PHY layer, so that's why we need high power efficiency and then higher efficiency, lower pin counts, and better and longer reach in the C-PHY layer. So that is the use case. Okay. And then, so these are the key takeaways in the D-PHY layer and C-PHY layer, how the PHY layer technologies must be matched with your transmission side and receiver side. It will be explaining that. Okay, and synchronous word. Yeah, Ram, tell me. Uh, huh. Synchronous means synchronous word and DSQ. So DSQ it is at the receiving side because we have different lanes. We have different lanes. Each lane different bytes of data we are transferring. Byte 0, byte 1, okay, byte 2. So in this way we are transmitting the data. I don't know who is who is reaching the destination side first. At that time, this queue will takes place. It is in the order way. Okay, 0, 1, 2, 3. In this order, it is placing that. And synchronous word is used to we are sending the data and then clock. So wherever the data is there and clock we need to place that, and data byte 0 is there, we need a clock, and byte 1 is there and we need a clock, and byte 2 is there, we need a clock. So that is the purpose synchronous words are placed in between the data. So that means your data and clock are aligned and then transmitting from the transmitter side to receiver side. Okay. Hmm. Fine. Ah, yeah, data is aligned with the clock. That is the reason we are adding the synchronous words in between the data bytes. Clear? See, multi-lane distribution and merging. How we are adding this multi-lane distribution and merging? See, we have lanes like lane distribution and then lane merging. In the distribution, that should be available in the transmitter side, and then merging is available in the receiver side. See, distribution means we are distributing the different lanes. Okay, byte words are there, so different byte lanes are there. Each byte lane is transmitting from the transmitting side to receiver side in a different manner, right? So we are transmitting the data from the transmitter side to receiver side. Byte 0 is transmitting byte 1, byte 2, byte 3, and then n number of bytes will be there. All the bytes are transmitting from the transmitter side to receiver side all the time at a time we are transmitting. Okay, so then lane how we are lane distribution management layer function is working here. So lane distribution function is working like all the data lanes are combined together, and then it is transmitting like this: lane 1, lane 2, lane 3, and lane n minus 1 we are transmitting. So that means it here the data is transmitting like a round robin type. So what is that round robin means? lane 1 data byte 1 we are byte 0 you are transmitting, after that byte 1. Okay, so in lane 1 you are sending that byte 0, and lane 2 you are sending byte 1, and lane 3 you are sending byte 3. So in this way it is transmitting. After that again lane 1 again, lane 2, lane 3, if you are using C-PHY lane, okay, C-PHY layer, so in the C-PHY layer we are using three different lanes. Okay, three different lanes are transmitting the data in different lanes. So in that way it is transmitting the data. See here, lane distribution management, we are transmitting the data by using D-PHY lane. How the D-PHY lane is transmitting means we are having two lanes in the lane 1 and lane 2. So in this lane 1, byte 0 is transmitting, and lane 2, byte 1 is transmitting. Again lane 1, again lane 2, lane 1, lane 2. So that means suppose two persons are there, or in a class 10 people are there. So 10 people, they are carrying their bags individually, so there is no problem. But one person only carrying that all the bags means that gives the problem to him, right? So same thing here also we are facing here. So that means different lanes will be distributing the work equally. So in that way, the lanes will be having the different bytes of data. That's why we are distributing the data bytes for the different lanes equally. Okay. So after that, this LMF is that what it is doing here. Lane merging function is used to combine that. So combine, see, because who is reaching first, I don't know. Suppose you are having one pipe is there. So one pipe is the water pipe is there, and then four tanks are there. So all these four tanks are filling. Who is filling first? Okay, who is sitting in the first, that will be filling first, after that second one, after that third one, after that fourth one. So why we are having this one lane and then the four process means remaining remaining will be in idle condition. Remaining will be idle condition means that is not creating any problem, and then we are avoiding that synchronous problem. So that means who is first, who is filling first, who is filling next, and whose data is receiving first. All these things will be avoided by using this lane management layer. Okay, so lane management layer will be distributing the work evenly. So who are working first, that data is transmitted, then again assigning the other data. And then lane 2 is there, other data is other byte lanes are transmitting. In that way, different lanes, different data are transmitting. See here also we are distributing like a byte 0, byte 1, byte 2, byte 3 we are transmitting. Okay, so that means you are using two lanes. In that lane 0, lane 1, byte 0 is transmitting, lane 1, byte 1 is transmitting. Or you are using four lanes in the lane 0, byte 0, byte 1, byte 2, byte 3. That means L1, L2, L3, L4. Again L1, L2, L3, L4. In that way, the work is divided. The bytes will be divided. Here, serializer and deserializer are there. Serializer means we are sending the data serially, and deserializer means so who is receiving first, that will be arranging in order. Okay, so that way also who is sending the first, which lane is sending for last, and that will be taken care by the serializer and deserializer. Clear? How the lane management, multi-lane distribution will be happening in this data lane, how the data will be transmitting from the transmitter side to receiver side. So why we are going for multi-lane distribution management, merging and distribution means, so we are having C-PHY layer and D-PHY layer. The main purpose is to increase the bandwidth, right? So how the utilization of the lanes, that is the main thing we are going for the lane management layer and then lane distribution layer. Okay, So in that lane management, we are having merging as well as distribution. In the distribution, we are using transmitter side, and then merging is used in receiver side. So the main usage is to increasing the bandwidth. So how efficiently we are sending the data from the transmitter side to receiver side. So this will take care of here. Okay. So in that way, the packets of bytes will be transmitted in a high-speed data lanes and then reconstructing, because while transmitting different lanes of data we are transmitting, and then again receiver side we need to reconstruct it. That means original byte streams we need to receive at the receiver side. So this functionality will take care of this lane management layer. Okay, one is lane distribution layer and other one is lane merging layer. Okay. Suppose in if you are transmitting different layers like round robin method, if you are not following the round robin method, means one will be the taking care more, one will be the affecting person. So that lane only most of the data bytes are transmitting. That's why we are going for the round robin method. Okay. So round robin method, that will take care of that each lane who is having the more bandwidth. So and then who is having the less bandwidth, then it will take care of that equally distributing all the data bytes. Okay. So that is the linear bandwidth scaling it is doing here. Okay, how the bandwidth is doing means linear bandwidth will be taking that. Okay, so linear bandwidth, what is that linear bandwidth means? What is how many lanes are there in that? How was the throughput will be transmitting? Okay, so because each lane having simultaneous start, right? So we are having start of transmission and end of transmission. So in between that different data we are transmitting, because based on the short packet method or long packet method we are using. Okay, long packet methods or short packet methods we are using, right? So that will support that. That will these short packet methods will support that low power states. This low power states will be transmitting the data like start of transmission, end of transmission, and then how many bytes are transmitting, and then what is the number of lanes will be transmitting from the transmitting side to receiver side. All these things will be taken care here. Okay, clear all these topics. Okay. So, and then we have different type of cases here. See, in this conceptual, this C-PHY layer, we are having byte 0, byte 1, byte 2, byte 3, and different bytes are transmitting, right? So, this lane trios we are having. In this different trio, see, positive layer and negative layer and positive negative, both layers are used. Okay, so same way compared to the D-PHY layer, C-PHY layer also transmitting the data. And here also we are using different lanes to transmit the data. Suppose lane 0, here 4 lanes are used. So lane 0, lane 1, lane 2, lane 3 and so on. So lane n, n number of lanes are used. In each lane, different bytes of data is transmitting. Okay, so how the transmitting is taking place means same way round robin method we are transmitting. That round robin method we are transmitting the data byte 0, byte 1, byte 2, byte 3 in the lane 1, lane 2. Suppose I am using 4 lanes. In these 4 lanes, lane 1, lane 2, lane 3, lane 4 is there. Okay, so and then I am transmitting 8 bytes of data. That means byte 0, byte 1, byte 2, byte 3. Same way again, byte 4, byte 5, byte 6, byte 7 is transmitting. Again byte 8, byte 9, byte 10, byte 11 will be transmitting. In this way the data will be transmitting. Okay. So suppose you are using 2 lanes, and then 6 bytes I want to transmit it. Okay, we are using 2 lanes and 6 bytes of data you are transmitting. That means lane 0 and lane 1. In this lane 0, byte 1 is transmitting, lane 2, lane 1, byte 2 is transmitting. And then here also byte 3 is transmitting, byte 4 is transmitting, byte 5 is transmitting, byte 6 is transmitting. In this way, the data will be transmitting. Clear? 0, 1, 2, 3 in that way we are transmitting. So uneven divisions are also, it is possible. Sometimes we are transmitting uneven divisions like so this byte lane 1 is not transmitting any data. Suppose 5 bytes only transmitting. Then up to this only lane 1 only transmitting. Lane 2 data is not transmitting any data. Okay. So that is the reason. Same way n number of lanes are there means, so we need to take care of that lane index. How the lane index will be there. Okay, so lane index will be maintained that. Okay, so lane index will be made depends upon the byte number. Okay, how many bytes are data you are transmitting, and then mod n. So that mod n represents that how many lanes you are using. Okay, this lane index will be taking care of that. Suppose 6 bytes of data you are transmitting and 2 lanes are using means, so 6 byte 2 mod, in that way they are utilizing that. Okay. Understood from me how the data will. Uh, mm, mm, mm. 2 digits of data. Mm, 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 mm. Fine. Yeah. Understood. Fine. So these are the same things I told you, right? Multi-lane distribution, merging, and D-PHY option and C-PHY option. I told you that byte 0, byte 1, byte 2, byte 3, and so on. So number of bytes will be transmitting, and then so different lanes will be receiving at the receiver side. So here a lane distribution, different lanes will be transmitting. See, here you are using 2 lane system. Here you are using 3 lane system, and then n lane system. So 2 lane system, I told you that byte 0, byte 1, byte 0 in the lane 1, lane 2 byte 1, byte 2 in the lane 1, byte 3 in lane 2. Okay, in that way data will be transmitting. Yeah. So in between the start of transmission and end of transmission, the bytes will be transmitting in the order. Okay, same order will be transmitting. Okay, the order will not be mismatch here. If not an integer value means, so that means not in multiples of 2, the lane will be earlier finishing. Someone is finishing earlier, someone is finishing later. Okay, uneven distributions are there means it is finishing later. So that means one lane is in operating, other lane in or idle condition. Then that data will be finishing first. Okay, here also see lane completion of different times. Okay, so how the lane 1 is transmitting the data, start of transmission 0, 1, 2 and 3 and so on. So different data are transmitting. And then valid data handling. How is handling the valid data? Lane 1, lane 2, lane 3 and so on. So lane n we are having all the data are transmitting independently. Okay, same thing. Short packet method we are transmitting n greater than 4. So that means you are using more than 4 lanes. That means 5 lanes are also supporting. So all these 5 lanes are also we need to transmit the data, right? In between the start of transmission and end of transmission. See, byte 0 is transmitting in lane 1, byte 1 is transmitting in lane 2, byte 2, byte 3. In this way, 4 bytes are transmitting. So across all the 4 lanes, and fifth lane to nth lane remains in low power state, that is not using. Okay, 4 bytes only we are transmitting and the remaining lanes are not using. So that is the lane independent operation. That means end of transmission and start of transmission it will be taking care of that. How the data flow will be taking place means the packet generator. What is the packet generator usage means the data how we are generating the packets. After that protocol layer will taking care of that how who is sending the data, and then who is receiving the data. So that will distributed by the distribution layer. After that, 5 layer will be there. This 5 layer is transmitting side to receiver side we are using. This will be receiving, and then here lane merging function is there. Here, sorry, Here lane distribution function is there. Here lane merging function is there. Okay, this lane merging function will receiving all the data and transmitting in the serialized way. Okay, so here serialized and here deserialized data packets will be there. Okay, so who is that lane merging is there? It will collect the data. It will collect the data and then reorder it. Whatever the orders you are receiving, and all are reordered. And then reconstruct that original data byte is same data byte is received or not. See, this is the lane merging function. See 0, 1, 2, 3 reconstructing the data bytes. So then only you are receiving the data. After that protocol layer and then packet decoder is there. So this packet decoder will decode the data. So then it will receive the data. Why this mechanism is important? I told you that bandwidth efficiently we need to use, and whose lane is efficiently transmitting the data. And then any EMI means electron migration interference is there, that will be avoided here. Okay. So what we need to check in this lane management, round robin is working properly or not. Okay, so are you following this round robin method or not? Okay, so that whose lanes are mapping correctly. So that means modulo mapping lanes are correcting or not. And then byte ordering, that means what are the bytes you are transmitting, all the bytes are ordered or not. So this byte order we need to take care of that byte ordering. Okay, after that byte ordering, how the synchronization checks that in between the start of transmission and end of transmission, how the data will be correcting. Okay, so if any lanes are idle behavior, that will receive the data first. Okay, so these are the checks we need to consider while transmitting the data. Okay, and receiving the data. Clear? Pranav? Hmm. So, shall we stop here or continue? Hmm. Yeah, tell me. Eh, Actually, what happened here means, suppose you are transmitting the data, how we are